and you had CD drives and computers, and I did a live boot and scared the shit out of myself because I had never seen an OS like that, and I thought I had broke the computer. So that was my first intro to Linux. Uh, why would I even want to give this talk? Uh, I kind of got infected with the Nix bug at work and then at home, and I've learned a lot from this. Uh, Shout out Tom for taking pictures. I see you. NixOS is a really large solution space. They're flexible and when applied carefully, I think they help make complex systems easier to maintain. And I'm interested in this because I think computers are hard. Um, we have software and hardware together. Um, the Apple people can make it look easy, but the rest of us have to like actually run systems, and I find that very difficult. So we have servers that are full of RAM and hardware, motherboards, and then on top of that, we have our applications running. And things get a little hairy sometimes. And when you start updating the OS or installing software, uh, you get to experience configuration drift, which I think we've all run into at one point in time. And it's a pain in the ass. So there's a lot of solutions to this. Um, you might have heard of one or two. So these are a few, some more, a little bit more, a little bit more. And so these are hardware and software that work together to achieve things, right? And I think that Nix is a good fit for a lot of these things to work together, specifically because of the hardware and software integration that we can do. Um, if you're like me, you've tried a bunch of these trying to make things work over time, or because someone said this was the fit, and or you were forced into it at work. Uh, I've done macOS management, I've done Windows management, Linux management now, and NixOS management. And I have to say that Nix and NixOS have been the best solution for me and for my home lab. And I've also found a really good fit for it at work too, which is at a pretty decent adoption rate. So people and organizations that run Nix, I do. So also at my job, we run this. So I work at a SaaS that does professional bomb part sourcing, forecasting, and managing supply chain risk. It's word salad, but it's a good product. And if you want to talk about it after the talk, reach out to me. I'm happy to share that with you. There are also some larger organizations like Anthropic, Anduril, Shopify, who also use Nix or NixOS as part of their deployments. I also heard recently that Replit uses that as well. So really interesting, diverse product space that's all use NixOS to achieve their end product and their sales product for their users. So why would you want to use Nix and NixOS? I think you want to use it because it's declarative, it's reproducible, and it's reliable. And a lot of things claim this, but I don't think a lot of things deliver this. And to make this more clear for those of us who are new or have forgotten, let me walk you through declarative versus imperative. So imperative is like a Subway sandwich. You walk up to the line, you're like, hey, I want a foot long on white. Let me get American cheese with turkey, bacon. Let me get some mustard, mayonnaise. I used to work at Subway, by the way, so this just comes naturally to me. And then after that, let me get some lettuce, tomato, a little bit of cucumber, some banana peppers. I want it toasted. We're gonna slice it in half. We're gonna wrap it up with a cookie and a drink. Right? That's a mouthful. Or we could just ask for number five, and you get the same thing, right? So that's the difference how I think about it. And it's a lot easier to ask for number five. This kind of translates into development and build environments for projects as well as hardware. And we talk about this. We do this at my job, and I'll talk about that a little bit more. The reproducible part is you can order a what's up, DEF CON photographer dude? You can order number five at any Subway across the country, right? And the nice part about that is Subways are widely available. So I can go to Alabama, I can go to New York, I can go to California, and I can ask for number five, and I'm gonna get the exact same thing. Um, so if you learned anything in this talk, it's that Nix and Subway are basically the same thing, and I want you to just drive that home. I see you taking a picture, sir. There you go. Yeah. Uh, Let me get in the details of how I kind of had my home lab run Ubuntu and how I switched it to NixOS. All right, so I started with a Lenovo small form factor PC that was e-waste from my corporate job. Uh, it put Ubuntu on it. I think it was like 16 or 18 at the time. And I ran Plex and some other things, and it worked good and sat in my living room, and my mom used it to watch Plex, and life was good, like super simple. Then I started having some storage issues, ran out of space, and migrated to a QNAP, which if you guys have seen those, they're pre-made storage appliances. The OS is really bad. The the built-in software is bad. They have their own version of Docker, their own version of like ZFS. Uh, but it was good for me at the time. Like I thought, like, all right, problem solved. I got some more storage. I don't really have to worry about this. I outgrew that. I've got a custom PC. I outgrew that. So now I have a 4U chassis and a rack at home. It's got about 15 drives in it, about 88 terabytes raw, and I'm looking to upgrading to 24 bay chassis soon, which I'm pretty excited about. But the home lab has grown, right? And my needs to manage that have also grown because I've started doing different things on there. Um, People talk about the learning curve for Nix, and I think it's real. Each time you modify your Nix config and then reapply it to the system, it rebuilds it. So you get a generation. And you can see my most recent rebuilds. Uh, I'm in number 366. It's been a lot of work, and I was surprised to see that number. It didn't feel like that much, but it thinking back, like the pain is definitely there. But it's helped me get better. So if you look here, you can see how my Etsy NixOS folder is organized for my home lab. On the base level, I have my configuration, my Flake Nix, some hardware information, and then a modules folder, which details how I like to organize some of the services I run on there. So just an example, I'm going to show you my Flake Nix first. Because the projector is a little washed out, the slides will be on my website after the talk, and there'll be a QR code at the end of the talk that you guys can grab too. But hopefully you can see everything okay. So I'll let you all read it, but basically I have some inputs and I got some outputs, right? And I'm inputting some package repos, specifically NixOS Unstable and an LLM agents repo. And those get put into outputs. And I also brew in my configuration.nix here. So pretty simple. If you're new to Nix, it's okay. Just follow along with me here, and we're gonna build the sandwich together. So next up is configuration.nix. I broke out the system like this to reduce risk of change overall and to make the main config easier. So all my system packages like Vim, Incus, btop, things like that are in the packages.nix. My users are in users.nix. I have an FTP set up, right? I have NVIDIA card in there, which I had to set up the drivers for, so that's its own little Nix file. And I just found this an easier method. And also, my motherboard is not professional grade, so I have a hacked together RTL 8157 file. I had to fight to get 1 gig networking working. That was not fun. I'm looking forward to putting a 10 gig card in there that's supported, but I was able to get it working, even though it wasn't natively supported in Nix. Like I talked about, I have 88 terabytes, which is a little bit of storage. And this is managed declaratively as well. Everything's defined at boot. So the system has predictable disk names. I've also got it configured so the system can boot with missing drives with no failures. So the main OS is set up on two mirrored NVMe drives, and the rest of it is spinning media. And you can see on the slide that the disk had been truncated, the list, but that's how it's set up, and that's how I have it mounted. And there's just some configuration options there. So this is a lot of stuff that Ubuntu just kind of handles for you natively, or it's very easy to set up. And Nix does this kind of under the hood for you. You'll boot up and it'll look at your hardware, and you don't necessarily have to define it, but I found a lot of power in defining it. And this is translated over to my job too. Lastly, I'll show you the NVIDIA Nix snippet. Everything has been defined and pinned. You can see the hashes there, and just some basic settings. I like to do local running like large language models, and so I've set up the CPU to support that a little better, or not the CPU, the GPU. And that was also not that bad to set up. I think I had more trouble setting it up on Ubuntu than I have on Nix. So next up, I'm going to talk about kind of how this started to go at work for me. The boss suggested we use Nix, and we started to look into it, and it started to be something that seemed possible, and started to get it to work. And at work, we use Incus to do containerization. Incus is different than Docker, and I think it's a little different than micro VMs that I learned about this morning. So we actually run NixOS. We run NixOS that runs Incus, and then in Incus, we run NixOS containers. Incus isn't that popular, so let me just give you the brief overview here. It's a secure system container, blah, blah, blah. Y'all can look it up on your own time, but this is the rough definition. You can just think of it as a container manager. So just like my job, or just like my house, my job was also traditionally an Ubuntu shop, and we still have some Ubuntu boxes running. We use Incus as our lightweight container management platform, and we have a CI/CD to do web application deployments. Also, from this slide on, everything has been done with my team, so not solo work. So I'll be talking about different projects here, and shout out my team for all the cool stuff we've been able to build. So we have a similar, or at my job, we've had the configuration drift issue, and we deploy a SaaS web application. And so on the Ubuntu boxes, over time, over deploys, over OSs, we just have drift. And it starts to become an issue when you need to do big changes or you want to manage things a little more efficiently. And it was nice to have the problem of growing, right? We just had some success and we got to make more boxes. Shout out our hardware team. We own our own boxes in a shared data center that they set up the box, bare metal, and we drop the OS on there and we go from there. Let's see, what else? We run custom software, which is custom metrics, which is custom monitoring stack with log collection, metrics forwarding, metrics modules for collection, right? So all this was custom written for Ubuntu. There were no pre-built Nix anythings. And this was a bit of a challenge. And it was fun to actually set up each of these individually as NixOS modules. The disadvantage of this is that nothing was on Nix packages. So these are our three pillars. We have job packages, job modules, and flakes. Excuse me. I've socialized so much the past couple of days. My voice is just like almost gone. I'm usually inside by myself in the dark computering, so it's nice to be here and talk about this, but my voice is kind of getting there. All right, so I've redacted the job name here. So job package is actually called something else, but you can just follow along and use your imagination. This is how we've made things work in our environment. There are lots of other ways to do it. This is one of those situations where we built the plane as we were flying it, slowly bringing NixOS into the fold for production while deploying Ubuntu boxes at the same time. We would load balance the OS behind a proxy to help mitigate risk and build confidence in the NixOS deployments. Our job packages is pinned to a Nix packages revision for the fleet, and every other flake follows that. So that gives us a fixed set of packages, and we can rely on that to always be the exact same when we deploy a new system. The job modules covers all the custom software I talked about that we deploy, and you can see some modules down there. CrowdStrike Falcon is an EDR solution that we also had to write a custom module for because they only support Linux and you can't pull from them natively without logging in to get the dev file. So this is pretty much how a production box would look with these modules on it. We import the module, set a host name and the IP, and we flip some enables and rebuild the box, and it's ready to go. We also have a custom auth module, which is SSH cert authority with host certs and principals files. It gives us access. It gives us AAA-based authentication using SSH, and we can use a ubuntu to authenticate into a jump box, and from there we can access servers using different identities. It's really secure. It works really well for us, and it works globally for us across all our boxes, across all our locations in the world. The nice part about this is that who can SSH into any box is recorded in a defined list, and we have the ability to audit that list as well. Like I talked about for CrowdStrike, this is how it was set up, and we just made it easy to turn on and enable. Some of the issues we saw with this is that NixOS doesn't have a user/lib, so the sensor's binary can't find the dynamic linker. The module fetches the vendor deb by content hash, unpacks it into opt at service start, and then launches it through NixLD to fake the FHS world it expects. So basically, this turns Nix as an unsupported platform into a Boolean. And because CrowdStrike requires a customer login to download the module, we pulled the deb and we host it ourselves on blob storage, and then our flake requests to pull that. So this is a redacted flake, so you get an idea how this looks. This is the first half. You just see that we have our input, which is that job packages repo I was talking about. And then we have our Falcon deb URL, some options, the second half of the config. So this is just to look at. You guys can download slides later. I don't want to read the config for you word by word. That's not helpful, but I think getting an idea of looking at it is useful in this context. We also set up the systemd stuff. You can see. So we started getting this working. We got some NixOS boxes online with our software, and we didn't have any issues. And things started to get a little more reliable, a little more consistent. And our team put some time in to define some of our production applications as infrastructure as code. We are also started defining our production hardware configuration as infrastructure as code. And then we started putting this in Git repos. And now we can do really cool things with that. It's taken a complex, messy world and made it pretty easy for us to work well across all the teams that are at the workplace, and also helped us work with our customers better. This was also years worth of work, right? Like we were deploying and doing customer work. Like this was not like a Nix sprint. This was at least 2.5, 3 years of work that we put in to get to this point. So we noticed devs were building their own Docker setups to emulate the whole product. It worked well enough that it became the default. But the catch is we don't ship Docker in production. We ship a tarball and we deploy that tarball to the box, and then it runs. Nix has allowed us to define the application as code, and we just ship the flake, build the flake, and then the application works. Because we have that flake defined, the team set up what we refer to as PR environments. So this allows a developer to submit a PR, and against that pull request, it spins up an entirely new environment that is as close to production as you can get, and they can see how their changes are. And we can spin a bunch of these up at one time. The QA people can see them, the developers can reach them, they have independent networking, and they're private. And it works great, right? It gives the developers independence to test their work easily, and it gives us as SRE team the confidence that it's going to work in production. The adoption was faster than we expected. It became the best way to deploy and evaluate PRs. And by year one, we regrouped and we had to scale it out, which I think is pretty cool. It's really hard to force adoption, but when it happens naturally, it really flows, and that's what I think we've experienced. Additionally, our customers have had a high customer acceptance, so they also test in these PR deployments, and we can spin them up for the customer, and they can get a good look at it as we help develop features alongside them. And this wasn't something we were able to do before, so it's just really enabled a different type of site reliability engineering that we weren't able to offer before. And I think it's given like our team a different level of confidence of shipping and making changes in production or in QA, because everything's well defined, it's reproducible. Just like I talked about with that Subway sandwich, it's really easy to just order number 5 again and have it spin up and be ready to go. So the last part is we got some things in beta. We have been building some tools to help spin up boxes really fast. I'm excited about these things. So they really aim to reduce the friction between I want like a server to SRE on and do things on, or a developer might want a server to develop on. Or even like we need a production deploy and a new AZ on bare metal. We need this by tomorrow. Like those are all situations that we can handle, and that wasn't something we could do a couple years ago, right? Like we're able to spin up a new box and production deployment really fast, and it used to not be like that. The goal that I would like to have is the ability to just kind of use the command line, type out like a binary path and call like make a new server with NixOS and pass it a repo or a repo URL or a local flake and be able to hit go. It'll go and rebuild on the Incus server and return to me the information I need, like the IP address, how to SSH in, make sure I have that SSH AAA authentication set up, and has all the monitoring stacks set up. Everything's reporting and sending logs back. And just have that really be a one-liner. And then on top of that, to build that into an API using Go, and then we'll integrate that into sort of an AWS control plane that we've been building locally, right? Like, so it's for us to monitor, to deploy, and do reporting on as well. So yeah, I'm really proud of the work that we've done. And this is the link to the slides. They'll be up in a couple minutes once I step down from stage. But yeah, thank you guys for coming to my talk. And if you have any questions, I will take them, but I don't know if I have answers. Thank you.